Lesson 1.6, Graphical Transformations. In this lesson, we're going to look at how vertical and horizontal translations, vertical and horizontal stretches and shrinks, and how reflections are going to affect the graph of basic functions. First, we need to discuss transformations. We talked about transformations in geometry when dealing with shapes on the coordinate plane. Now we're going to discuss transformations affecting equations and graphs. So first, what is a transformation? It is a function that maps real numbers to real numbers. We have two different types of transformations. First, we have rigid transformations, which leave the size and shape of the graph unchanged. Okay, so these include horizontal translations, vertical translations, reflections, or any combination of those. Okay, they preserve the size of the graph. A non-rigid transformation is going to distort the graph in some way. These are going to include horizontal and vertical stretches and shrinks. The first types of rigid transformations we are going to talk about are vertical and horizontal translations. You can see the notation down below we have for horizontal translations. If we're subtracting that constant within the function, that is a translation to the right. If we're adding that constant within the function, it's going to be a translation to the left. Those are both horizontal. If we have a vertical translation, then we are adding or subtracting some constant to the end of the function. So if we're adding c, that means we're translating up. If we're subtracting that constant, it's a translation down. In this first example, we are going to find the equation for each translation. So we're starting with a basic function y sub 1 equals x cubed, starting with our cubing function, and then we're either going to have a translation up or down, a vertical, or a translation left or right, horizontal. So using the graph and the ideas we talked about on the previous slide with those types of translations, we're going to write the equation for each one. So in part A, we have y sub 2 is going to be equal to, if we started with the red graph, this is y equals x cubed. All we did was translate down 3 units. So we have our basic function, y equals x cubed, and we would subtract 3 at the end to indicate that we moved down 3 units. If we look at graph B, okay, we started in the middle at the origin with y equals x cubed. We translated left 2 units. So with our y sub 2 equation, since it's a horizontal translation that occurs within the function, so inside parentheses we have x, we move to the left, so it's plus 2 quantity cubed. That indicates we have a horizontal translation going left 2 units. And finally, the third one, we started at the origin, we translated 3 units to the right, so our y sub 2 equation will be equal to, inside the parentheses we have x minus 3. So since we're subtracting, that's indicating we're moving to the right 3 units. One thing that tends to be a little confusing with these is the horizontal translation. Vertical translations are fairly easy because if we're subtracting 3 at the end, that just means we're moving down. If this had been a plus 3 at the end, we would be moving up. When we're talking about horizontal translations, it's the opposite. So even though we have plus 2, that means we're moving to the left, which we typically think as a negative value. So one way to remember whether to move left or right, set what is inside the parentheses equal to 0. So if you would set x plus 2 equal to 0 and solve, you would get x equals negative 2, meaning you would move to the left. If you take this last example, if you would set this equal to 0, x minus 3 equals 0, so x is equal to 3, indicating we're going 3 units to the right. Okay, so understand when we're subtracting this value inside the parentheses, that actually means we're moving in the positive direction, moving right. Below is another example showing you how we can perform a vertical translation. So if we start with f of x equals, this is the absolute value of x, how can that be transformed to get the graph of y equals the absolute value of x minus 4? So since we're subtracting 4 at the end, that is just a vertical translation 4 units down. So we start with our basic absolute value function and simply shift that whole graph 4 units down. The next type of rigid transformation we're going to discuss is reflections. Okay, we have three basic types of reflections. We have two that are most common, and then the third one is a combination of both. So if we're going to reflect across the x-axis, all we're going to do is negate all of our values. So we're going to make all of the values, y values, negative. If it's a reflection across the y-axis, we're negating all of the x values. So our y values stay the same, the only thing that changes are the x values. So to the right, here would be a reflection. If we started with the blue graph, this is a reflection across the x-axis. Notice our x values don't change, only the y values do. The graph down below, this is a reflection across the y-axis. Okay, our x values change, our y values do not. And then we also have a reflection across the origin, which is going to be a combination of both. Our x values are going to change to the opposite. We're going to negate those, and we also negate the y values. The last types of transformations we are going to discuss are non-rigid transformations, meaning our shape is going to be distorted in some way. So first we have horizontal stretches or shrinks. So suppose we have the letter C, which represents some positive real number. If we're taking all the values inside our function, all the x values, and dividing them by that number C, it's going to be a stretch if C is greater than 1, and it's going to be a horizontal shrink if C is less than 1. Then we also have vertical stretches or shrinks. So if we're taking that positive real number C and multiplying it out inside or out in front of our function, it's going to be a stretch if C is greater than 1. It's going to be a shrink if C is less than 1. In this next example, we want to find equations for stretches and shrinks. So we have the curve C sub 1, which is defined by the equation y sub 1 equals x cubed plus 3. In part A, we want to perform a vertical stretch on that equation by a factor of 4. So for C sub 2, that curve, we're going to have the equation y sub 2 is equal to, if this is a vertical stretch by a factor of 4, that means we're multiplying this whole equation by 4. We're taking 4 times our original function, so 4 times x cubed plus 3, which is going to be equal to 4x cubed plus 12. So since we just have a vertical stretch, we multiply our original equation by a factor of 4. In part B, we want to find an equation where we take our original C sub 1 and perform a horizontal shrink by a factor of 1/3. So our equation is y sub 3 equal to, in our equation, our original, we have x cubed plus 3. Everywhere we have an x, we're going to divide that by our constant. So we're taking that x divided by, it's a factor of 1/3, so we're dividing by 1/3. And we have that quantity cubed, and then plus 3 at the end. If we're dividing by a fraction, that's the same as multiplying by the reciprocal. So the reciprocal of 1/3 is 3. So we can simply write this as 3x quantity cubed plus 3, which if we distribute that out, 3 cubed is 27. So this is 27x cubed plus 3. This is the equation we get when we perform a horizontal shrink by a factor of 1/3 on the original. In the last example, we want to combine many different transformations. So we're going to start with the basic equation of our squaring function, y equals x squared, and perform the following transformations. Now it's important to remember that the order in which these transformations are performed will most likely affect the final result. Okay, so if we would interchange the order in which we perform some of these transformations, our end result is going to change. So make sure you are always performing these in the order in which they are indicated. So first we're going to start with a horizontal shift 5 units to the left. So if we're taking our base equation y equals x squared, and then we perform that horizontal shift 5 units to the left, that means inside parentheses we have x plus 5 quantity squared. Now we're going to go and perform this second transformation of vertical stretch by a factor of 3, which means we're multiplying 3 out in front of this function. So we have 3 times the quantity x plus 5 squared, and then a vertical translation 4 units up. So finally we have 3 times the quantity x plus 5 squared, and then vertical translation 4 units up, we'd have plus 4 at the end. Okay, so now just for practice, we're going to simplify, FOIL out, and simplify this result. So we have y is equal to 3 times, if we have x plus 5 times x plus 5, we would get x squared plus 10x plus 25, and then plus 4 at the end. If we distribute this 3 through to each term, we'd have 3x squared plus 30x, and then plus 3 times 25 is 75. 75 plus 4, we would have plus 79 at the end. So after a horizontal shift of 5 units to the left, a vertical stretch by a factor of 3, and a vertical translation 4 units up, this is the end result for our graph. So what I would recommend you do is to grab a graphing calculator, graph our basic function, and then graph this one in y sub 2 so that you can see how these all affect the look of our graph.